Okay, now that we have both of our pieces of geometry created, the ceiling grid system and the NURBS curve on the floor plane, let's get set up so we can do some analysis here. First of all, we're not going to use the cuboids. That's a visualization of an object around an array that we have. So I'm just going to disconnect that temporarily. You'll notice that cuboid goes right back to the start. And I'm going to turn the grid back on by turning the preview on, or the array, should I say. And now in this function, we're going to use well, will seem like obscure. It's a function of calculating a point, a relationship of one object to another one to find out what the closest point is. In this case, any given point here, I want to find what is the closest point along this line. And then use that distance to calculate how I'm going to affect the way that grid system looks. And we'll just kind of go through this step by step, and it'll become a little more clear. So right away I'm going to search for this one because I don't exactly know where it is in the list. It's geometry dot closest. So if you start typing that, eventually closest point to, and you'll notice I'll just stay on this for a second so you can see that graphic. There's got two objects and then a measurement between them to find out, kind of indicating that it has the ability to identify two points on separate geometry that are closest to each other. So I'm going to select that one. We'll take a look at how that works. So I have two sets of geometry here. I have one which is our array, and the other one which is our NURBS curve. And if I was to say I want to make, it doesn't really matter which one here is really the primary. I'm going to put in both I'll use the NURBS curve as the other geometry and the array as the base geometry. And I come up with 121 lines. And those are all points along the NURBS curve that relate to another point that's up here. And really the only way to visualize that is to actually start connecting the dots, so to speak, connecting the point that's here with an equal one that's in the array. So I'm going to use another function just to create a line. Let's see if we can find that in geometry. Turn off abstract, and I'm going to look for curve. It's probably under curves. Oh, it's not. Oh, yes, it is. Good. Line. And I'm going to use a line by a start and an end point. And we'll feed this with some data. So we'll make the start point the NURBS curve, and the end point's a point on the array. And now we get this, what looks like a super convoluted bunch of lines. But each one of those lines tells a story that a specific point here, its closest point, or its closest distance along this whole line is that very end connection of that element there. And if we were to kind of zoom in here a little bit, a lot of these end ones are all converging on that same point, but then there's many that are all just all over the place here. And it'll be interesting to see what kind of an effect this creates with our ceiling panels as we start to build it out. So I'll go back to the definition, and I think, let's see how many minutes we're into this here. I guess we're going to want to do one more thing. What I'm going to do is actually hide this line by start and end point because it looks a little bit busy. And I'm now going to extract some data from it. So we have 121 lines, and those lines all have a length to them. So what I want to do is I want to be able to find out what that length is. So let's see if we can extract some information here. I'm going to actually use a shortcut right away because I know what it is. It's curve dot length. And if we plug that line into as a curve, we get an output which is the length of every one of those lines. And I'll make it more permanent. I'm going to open up another tool we have. It's called a watch box. And I can plug this data into here, and then we can come in and see what it looks like as far as a list of data. So we have the distance between, and this makes sense if you think about it, nothing could be any shorter than 20 feet because our NURBS is on the floor plate and our points up here are 20 feet above in the ceiling plane. So our lowest value is going to be 20, and our highest values will vary. It looks like up to about maybe 20, 23, or 24, maybe even all the way up to 25. And this made a list of lists, which is just something to keep in mind right now. That's absolutely critical to our calculations. But now we have this idea of the length of, or a numerical value assigned to each one of these points. And actually now if we went back and just for fun, if we put our cuboids back in place and we use this value to do the height, and we zoom way out, you can now see that we get a curvature responding to that curve. So it's totally uncontrolled at this point. We've just plugged some data together. Obviously we don't want to make things that are that long, but that is the 20, the minimum value here is 20, the maximum value is probably 25. And what we really want to do is get some sense of this curvature, but in a much smaller profile. So we'll look at ways to modify that in the next clip.